Good morning, friends. As usually, this is Mr. Virat Kumar, lecturer in electrical and electronics engineering. Before 1 week, we have seen a class regarding ellipse, regarding conic sections. In that, we have seen about ellipse, how to draw ellipse. So we have seen some 6 methods. Out of those 6, we have gone through only first 3, like concentric circles method, rectangle method, and oblong method. So now today we'll see about the rest of 3 methods, that is arcs of circle method, rhombus method, and basic locus method. And if time permits, we'll also move on to the next topic called parabola. So we'll see a small recap of these things. So this is slightly about the ellipse. We have seen the concentric circles method. You can see here, this is the concentric circles method. This is rectangle method, and this is oblong method. So I hope you have gone through all these 3 methods and practiced well in your sheets. So since I have been for a week, I have gone through some FTP programs. So I am after a week to you. So we will see the rest of the methods to draw an ellipse. So today we will see about how to draw an ellipse by using arcs of circle method. How to draw an ellipse by arcs of circle method. As usually, we will not go into the concept of that. We will just make a problem. We will note a problem and we will solve it. By that, we will be knowing both the theory and practical of it. See the problem of it. Major axis AB and minor axis CD are of about 100 mm and 70 mm long respectively. So draw an ellipse by arcs of circle method. See, there are some following steps how to make this ellipse by arcs of circles method. We'll just go through them one by one and we'll make the diagram. So the steps involved in it are: the first one is draw both axes as usual and name the ends of intersection points. And the second step, taking AO distance therefore half major axis from C, mark F1 and F2 on AB. That's called focus 1 and 2. And third step, on line F1 to O, taking any distance, mark points 1, 2, 3 and 4. The fourth step, taking F1 as center, with distance A to 1, draw an arc above AB, and taking F2 center with B to 1 distance, cut this arc. So we will be getting a intersection and name the point as P1. The fifth step is repeat this step with the same centers, but now taking A2 and B2 distances from drawing arcs, and name the points P2, P3 and so on. Similarly, get all the points with same steps positions, with same steps of position of P can be located below AB. Join all points by smooth curve to get an ellipse. Just note down the steps so that you will be able to analyze it. One second. So okay, before making, we'll just make the diagram and then we'll make the steps. We'll see it by serially. For the first step, draw both the axes usually and name the ends of the intersection points. See, it's a major axis and a minor axis. Major axis of 100 mm and minor axis of 70 mm with the center of it O. Now taking AO distance, therefore half major axis from C, mark F1 and F2 on AB so that the focus is 1 and 2. See A1 OB, mark them as focus 1 and focus 2. So C to F1 is the distance of AO and C to F2 is the distance of same AO or OB. So it's saying that taking AO distance, therefore half the major axis. If it is 100 mm, it will be of about 50 mm. So taking half the major axis, and from C as center, mark F1 and F2 on AB line so that they are called the focus points of F1 and F2. Now what's the third step? On line F1 to O, taking any distance, mark 1, 2, 3, 4. So make some 4 points. See here, from F1 to O, that will be some particular distance. So taking any distance, mark points 1, 2, 3 and 4. That may not be equally displaced. So these are some 4 points and name them 1, 2, 3 and 4. Now taking F1 center with distance A to 1, draw an arc above AB and taking F2 as center with B and 1 as distance, cut the arc. See the procedure. So with F1 as center and A to 1 as distance, we have drawn a line, and similarly B as center, F2 as center, B to 1 as radius, draw a line from F2. So these both intersect at a point that is called P1. See, this is the second one for P2. So it's telling you to repeat this step for same centers. So you'll be getting P1, P2, P3 and P4. So you name them. So you have got a quarter ellipse on the left top of your figure. So similarly, on the right top of your figure, point them and join the points with a smooth curve. Similarly, in the left bottom and right bottom, you will be getting the points and join all these points smoothly in order to obtain an ellipse. So this is very simple method which is called by arcs of circle method. So I hope you have got the point. So now I'll just give you some time to make the note of it. So make clearly to the steps and to the diagram. So once you just make the steps, after that we'll again see the diagram too. Make the steps. Are you making the steps or not? So make the first step, second step, third one, fourth, fifth, 7. The total is 7 steps. Oh. Is it okay? So we'll see it again. Draw both the axes as usual and name the ends. So the major axis of AB and the minor axis of CD with 100 mm and 70 mm. At the center O, now AO as center, draw a line from C to AO, similarly from C to OB, and mark the points as F1 and F2, where F is called as focus points. And now from F1 to O will be some particular distance. Divide that into some four parts that may not be in equidistance. See, there are 4 parts, may not be in equal, and name them as 1, 2, 3 and 4. Now with F1 as center, A to 1 as distance, draw a line from F1. Similarly with F2 as center, B to 1 as distance, draw a line from F2. So this F1 line and F2 line intersects somewhere, there you just mark as P1. So similarly follow the steps from A to 2 with F1 as center and B to 2 with F2 as center, and mark all those intersections with P1, P2, P3 and P4. We'll see the procedure. See, from F1 and F2 with A1 and B1, similarly F1 with A2, and from F2 it's B2. So repeat these steps for all the 4 points and name all these intersections as P1. Mark them. Firstly you just mark them and mark it as P1, P2, P3 and P4. Now we got total 4 points including the adjacent points of A and C. So join all these points with a smooth curve. So you have got a quarter ellipse in the left top of your figure. So repeat the same procedures towards your right top. So you'll be getting same 4 points and mark them and join with a smooth curve. Similarly to the right left, right bottom and left bottom. Join all these points in order to obtain a smooth curve which is called our ellipse. So this is our ellipse. Is it clear? So just make it fast. If it is done with you, we'll just move on to the next method. Okay, then we'll move on to the next method. See here, he's saying something about this. As per the definition, ellipse is locus of point P moving in a plane such that the sum of its distances from two fixed points f1 and f2 remains constant and equals to the length of major axis AB. Note, A21 plus B21 is equals to A22 plus B22, that is equals to AB. Okay, then we will move on to the next method. See, the next method is draw an ellipse by using rhombus method. Make the equation for that. It's problem number 5. Draw a rhombus of 100 mm and 70 mm long diagonals and inscribe an ellipse in it. So this is the rhombus method. So first we need to draw a rhombus of 100 mm and 70 mm long with the diagonals and inscribe an ellipse in it. We'll see some steps to draw this. The first step is draw a rhombus of given dimensions. Here I had given you 100 mm and 70 mm. With those dimensions you need to make a rhombus and mark midpoints of all sides and name them as A, B, C and D. Mark midpoints of all sides and mark them or name them as A, B, C and D. Now join these points to the ends of smaller diagonals and mark the points as 1, 2, 3 and 4 as 4 centers. The fifth step is taking 1 as center and 1 to E as radius, draw an arc of AB. The sixth step, same, taking 2 as center, draw an arc CD. Similarly, take 3 and 4 as centers and 3 to D as radius, draw arcs DA and BC. So I think there will be some points, intersections, and you will be obtaining some points. If we join all those points with a smooth curve, then we may obtain an ellipse. So we will see the diagram. See, firstly we have drawn a rhombus, as we know how the rhombus looks, with the diagonals of 100 mm and 70 mm, which is quite natural, which is a major axis and minor axis. Now he said us to mark midpoints of all sides. Since we have 4 sides in a rhombus, so in that mark midpoints of all sides and name them as A, B, C and D. So for this rhombus we have marked the center points and we are naming it as A, B, C and D. Now he is saying just join these points to the ends of the smaller diagonals. Join these points to the ends of smaller diagonals. Okay, it's done with that. Now mark points 1, 2, 3, 4 as 4 centers. So these are 1, 2, 3 and 4 centers. Now taking 1 as center, so here you look 1 and 1 to A as radius, draw an arc on AB. Draw an arc ABC, taking 1 as center and 1 to A as radius, draw an arc AB. Now same, taking 2 as center, draw an arc CD. Is it okay? Now similarly 3 and 4 as centers, 3 and 4 as centers and 3D radius, draw arc DA and BC. See, 3 as center, 3 and D as radius, draw an arc AD and BC. So we will obtain an ellipse by using rhombus method. I think this is very simple method to you. You just note down the question and steps involved in it. We'll see it again. Okay, make the steps. Okay, see the steps once again. We have drawn a rhombus with the diagonals of it AB and CD. Now mark the midpoints of all the four sides of the rhombus and name them as ABCD. Now join these points to the ends of the smaller diagonal. Okay, and mark the points as 1, 2, 3 and 4. Now 1 as center and 1 to A as radius, draw an arc AB. Similarly 2 as center, 2 to D as radius, draw an arc DC. Similarly 3 as center, 3 to D as radius, draw an arc AD. And similarly 4 as center, 4 to C as radius, draw an arc PC. It's very simple. So we have got an ellipse with a very simple method. This is an ellipse. So very simple method. Just note it down. Okay, if we're done with this, we'll move on to the next method. I think that is the last method to draw an ellipse, which is nothing but the focus method or foci method. Okay, if we're done with this, we'll move on to the next method. Okay, the next method is draw an ellipse by using directrix focus method. So firstly, we'll see the question and steps and then the diagram. See here, it's a problem number 6. Point F is 50 mm from a line AB, and A point P is moving in a plane such that the ratio of its distance from F and line AB remains constant and equal to 2 by 3. Draw locus of point P, nothing but the eccentricity is equal to 2 by 3. We have seen in the first class that there is an eccentricity for both, for all these conic curves like ellipse, parabola and hyperbola. We have seen for ellipse the eccentricity, nothing but the ratio of eccentricity is less than 1, that means 2 by 3. So make the question. Okay, see the steps involved in it. Draw a vertical line AB and point F 50 mm from it. Now the second step is divide 50 mm distance in 5 parts. And the third step is name second part from F as V. It is 20 mm and 30 mm from F and AB line respectively. It is first point giving ratio of its distance from F and AB. It's 2 by 3 and therefore 20 by 30 mm. So fourth step, form more points giving same ratio such as 30, 45, 40, 60, 50, 75, etc. Taking 45, 60 and 75 mm distance from line AB, draw 3 vertical lines to the right side of it. The sixth step, now with 30, 40 and 50 mm distances in compass, cut these lines above and below with F as center. Join these points through V in smooth curve. This is your required locus of P and it is an ellipse. Okay, we'll see the diagram. This is actually called a directrix focus method. The vertical line is called directrix and the horizontal line is called focus. See, the vertical line AB is called directrix and the horizontal line is called focus. So it's telling us to draw a vertical line AB and point F at the center, 50 mm from it. I don't know, from that 50 mm from it. In point F, so from the AB CC, from here, this center to here, this center to here, that will be 50, that will be 50. Okay, now divide this 50 mm distance in 5 parts. That may not be in equidistance. No, that should be equal. Sorry, divide this 50 mm line into 5 equal parts, and the name second part from F as V. From F, the second part as V, that is about 20 mm. It is 20 mm and 30 mm from F and AB line respectively. So whereas V is called vertex and F is called focus. So this is like 20 by, so from F to V is 20 and V to AB line is 30. So this is like 20 by 30 ratio, nothing but 2 by 3 ratio. So the eccentricity is 2 by 3. If we just make in this order only, we will be obtaining an ellipse. Now from form more points giving same ratio such as 30 by 45, 40 by 60, 50 by 75, etc. Thirty by 45, a line, and the next is 40 by 60, and the next is 50 by 75. Mark those points on both upper and lower. I join these points in order to obtain an ellipse. So this is your required ellipse. So this is the parabola. Okay, so this is your required ellipse. You may need not to draw the entire ellipse in a closed path. You can just show in this way also. Okay, so in this you need to remember these ratios like 30 by 45 and 40 by 60, 50 by 75. So for all these things you need to get a ratio of 2 by 3 only. So now see, 30 by 45 gets you, so 15 2 is 30 and 15 3 is 45. It's 2 by in the order of 2 by 3 ratio. Similarly 40 by 60, 22s and 23s, and similarly 50 by 75, 25 2s and 25 3s. So taking 45, 60 and 75 mm distances from the line AB, draw 3 vertical lines to the right side of it, and now with 30, 40 and 50 distances in compass, cut these lines above and below with F as center. Is it clear? So join these points through V vertex in smooth curve in order to obtain an ellipse. Okay, just make the steps. We'll see the diagram again. Okay, firstly we need to draw a vertical line of AB and point F 50 mm from it. So this is an AB and the line, horizontal line, is called a focus. Mark a point 50 mm from AB directrix and divide this 50 mm line into 5 equal parts, and mark the second point from F as V, which is called vertex. So from F to the line AB in between V, it's in a order of 20 by 30, nothing but 2 by 3 ratio. And in order to obtain more number of points in the same ratio like 30 by 45, 40 by 60, 50 by 75, towards right to the directrix. So firstly at the distance of 45, with 30 F as center, we'll just cut an arc. So this vertical line is of about 45 mm, and from F as center with 30 mm as radius, we'll cut an arc. Similarly for 40, 60 and 50, 75, and mark the points on both upper and lower. So this second line will be at a distance of 60, and the intersection will be with 40 mm. Similarly the third. So mark all the intersections on both upper and lower. So join all these points through the vertex B smoothly in order to obtain your required ellipse. See, this is your required ellipse. Is it clear? So in this method you need not to make the closed path of your ellipse. You can show the half sectional view also. Just note it down. Sorry. Okay, this is your ellipse by directrix focus method. So by this we have gone through all the methods of ellipse, like about 6 methods. See, we have seen about the ellipse with concentric circle method, rectangle method, oblong method in the previous class, and in the today's session we have seen about arc of circles method, rhombus method, and basic locus method, which is also well known as directrix focus method. Okay, almost the time is end. We left only about 5 minutes, so we'll see a brief introduction of parabola. See, from parabola, in parabola we have only 3 methods. One is rectangle method, the second one is method of tangents, nothing but triangle method, and the third one is basic locus method or directrix method. So we mostly see this basic locus method in all the 3 conic sections. So it is a general method to draw these conic curves in an engineering curves. So either ellipse or parabola or hyperbola. So the general method is basic locus method. So this will be in every conic section. So similarly in parabola also we have seen a basic locus method, a directrix method. So along with that we will be seeing rectangle method and triangle method. See, rectangle method, method of tangents nothing but triangle method, and basic locus method. So in the conic sections already we have seen about an ellipse. Now we will see about parabola. See, this is a parabola. How a parabola is drawn? This is a cone. See, this is a cone and with a center axis line. If that cone is intersected a sectional plane parallel to the end generator, these are called end generators, either this or this. So for that, a section plane parallel to that end, if it is cut by a section plane parallel to that end generator, and if that portion has been removed, and if we see the cut portion, it appears, the curve appears like a parabola that you can see over here in three-dimensional view. So this is the curve of parabola. Okay, so in this parabola we have three methods. One is rectangle method and the other is triangle method and the other is basic locus method or directrix focus method. So I think we'll see all these three in the next session. I think in the next section the entire parabola will be able to complete. So we'll see the today's summary. We have seen about this ellipse by arcs of circles method. I hope you have understood very well, and we have seen ellipse by rhombus method. I think this is also very fine with you. And also we have seen about the ellipse by directrix focus method. So from all these 6 methods, a directrix focus method is a general method, so which is involved in all the 3 conic curves. Okay, so thank you for today's session. Thank you one and all. And a drawing is a subject regarding to the practical one, and you need to practice well. By seeing you may not be able to understand perfectly, but by practicing you will be understanding. Finally, thank you one and all.